Alright, in this video I'm going to show you how to make a thick origami model using the offset panel technique. The pattern we're going to use is this hexagonal twist. So this is a model of what it would look like in paper. So let's get started making a thick one of these. First thing I'm going to do is I'm going to create a new part, and I'm going to recreate the fold pattern. And actually before that, I'm going to go in and make some global variables just for some of the main dimensions in the fold pattern. That makes it easy to change if I want to. So I'm going to make one for the outer diameter, the outer hexagon. I'm going to make it 9 inches, and the inner diameter we're going to do 6 inches. And while I'm at it, I'm going to make one for material thickness, because we are making this in thick materials, and I'm going to make that 1/4 inch. Alright, so here's my fold pattern. So what I'm going to do next is I'm going to make an extrusion for each of the different panels. And as I mentioned earlier, it's pretty symmetric, so a lot of these parts, a lot of the panels are identical. So I'm just going to do I'm going to make an extrusion for this panel here, one for this one, and this one. And I'm going to do them in a certain order, and I'll show you here with this paper model how I choose the order. I like to do it in the order of how the panels stack in the model. You'll see that this one's on the bottom. This panel here will stack right on top of that one. So we'll call it number 2. This one we'll call number 3 because it stacks next. And then lastly is that top rectangular panel. So that will be the order that I do this in. It just kind of helps keep things organized. So I'll select the area, the panel I want to extrude, and I'm going to extrude it amount of the material thickness. Then you just select that same sketch, say extrude again, select your panel, and then this is important, you got to be sure to uncheck the merge result box, otherwise you end up with only one body. And again, we use the material thickness, and I'm just going to do that same thing for the other 2 panels. Okay, so now I have all of these extrusions, and you might be wondering why I'm doing this all in one file, because you can't move different bodies in a part file. But what I like to do it, I like to have the whole crease pattern defined by one sketch, because then it's really easy to change all of your panels at once if you wanted to. I could go in and change one of these global variables. You'll see now. Let's just say make this 10 inches instead of 9, and it changes all of my panels at once. So that makes it nice. I'm going to change that back. And then now I'll show you how to kind of divide it up into different parts. and maybe I shouldn't use the word parts because it's all the same part, but we're going to use different configurations. So I'm going to make a configuration for each of the panels. Oops. And then we will assign a single extrusion to each of those configurations. So I'm just going to leave the default with all of them unsuppressed. Then for my number 1 configuration, this is the panel I want, so I will suppress the others. Here's my number 2, so I'll suppress these, and so on. So now I have my panel number 1, 2, 3, 4. And I'm going to make a new assembly and insert that part. So the way you deal with configurations in an assembly, you can have multiple instances of the same part, but use different configurations of that part. So you just right click and go to configure part and choose the configuration you want. And then if you hold control and drag your part, you can easily make a copy of it. And then I'll go in and change this one to be configuration number 2. So in this assembly, what we're going to do is we're going to create the stacked fold pattern. So we're going to stack it as if, just in the same way that this paper model stacks. So we got panel number 1 on the bottom. Here is panel 2. Flip it over on top. So it doesn't really matter very much how you constrain these parts, because we're going to end up, well, nothing's going to be moving. You'll see in the next model that it will matter a lot, but this one doesn't. So now I'm going to add an axis so that I can just rotate some of these parts around in a pattern feature. Okay, so now I have my stacked model. Let's go back and look at the paper model, and you'll see that it is stacked just in the same way. So that's what we got. So the next step is to choose a plane, a joint plane. You'll see in this paper model that when it's completely folded up, all of those rotational axes, and even all the panels in this case, lie on a single plane. So that's what we want with this model, because that is really the idea behind the offset panel technique, that we're adding thickness to these panels, and then we're offsetting, we're going to add offsets to get those rotational axes to be in the exact same spot as they are in the paper model. So when you choose a joint plane, technically it can be anywhere in any orientation, but it makes things a lot easier if, one, it's parallel to the panels, and also if it is towards the middle of the stack. Otherwise, you're going to have offsets that are really long, and you'll probably have more offsets as well. So I'm going to choose this plane. So now what we need to do is we need to create those offsets so that we can get our hinges back onto this plane. And we need to do that for each fold in the fold pattern. So we'll use this as a model. So let's start with this panel. Right now it is, one material thickness away from the joint plane. And there is a crease along every edge of this hexagon. So I'm going to go in. I like to just edit the part right in the assembly. That makes it nice and easy to see, the other panels and kind of what's going on there. So I'm going to go ahead and add 2 offsets, and then I'll show you why I have added them where in the location that I have. Okay, so I have 2 offsets on this hexagon on my panel number 1. And you'll see that they both come right up to our joint plane. So, and you'll also notice that one of them, when looking at it from the top, I kind of drew on the inside of the hexagon, the other on the outside. Now this is important because we want all of the axes not to only be on this plane, but we want them to be on the same exact location in the crease pattern that they are in our paper model here. Oh. So you can see the shape that we're making, and that is going to match our rotational axes in this model. Now, deciding how to do the offsets depends on a couple of things. So it depends on where the 2 panels are relative to the joint plane. So, for example, here, this offset, we want our rotational axis to be here. So we use that edge. And I'm just going to bring another one down to match up to this face. And this will be our axis, this edge will. And that is because this panel is going to rotate over this way. So if you can kind of imagine how if this offset was on the outside of the hexagon, like this one is, and this one had one to match it, that it wouldn't let it rotate this way. So that's why that's kind of how you choose how to do the offsets. And really, they can be any shape as long as you have, and they can be any length, as long as you have this edge here to act as your rotational axis. And then this one here, we're going to use this edge, right? Because the hinge, the fold, is along this edge of the hexagon, and it's got to be on the plane. So that's how you choose how to do your offsets. So now I'm just going to pattern these. Okay, so now just looking at our panel number 1 in our fold pattern, it only has the 6 folds, and we have 6 rotational axes here, so we're good. We've done all of the offsets for panel number 1. Now let's look at panel number 2. Panel number 2 lies on the joint plane. So we have all of the rotational axes. We have one here, and one here. So they're all in the correct location already. We don't need to add any offsets to panel number 2. And that goes for number 3 as well, since our joint plane is right between panel 2 and 3. Number 4, however, we need to add some offsets to. So let's go ahead and edit panel number 4. And it has an axis here, here, and here. I'm going to do one. I'm going to do the one that matches up with the with our panel number 1. Okay, so there's one offset for panel number 4. Now, how do we get this rotational axis back to meet with panel 4 and 3? This is the edge that we're going to use on panel 3. So how we're going to do that, I'm going to go right back into edit panel number 4. You know what, let me show you, for example, how the shape doesn't matter. Just as long as you have some kind of edge, some kind of rotational axis edge, you're fine. So I'm just going to make it super short, and I'm going to throw on an arc. Oops. Okay, so if I do it on the inside of this panel, we're going to have interference with panel number 3. So let me flip this around. So it's going to be kind of a funky looking offset, but it doesn't matter. Oh, and I need to mirror that in the sketch. Okay, so that should take care of all of my folds, all of my hinges. They all lie on the joint plane right now, and they're all in their location in this plane as well. So now we have all the parts. We have all the panels. Let's just make a model real quick that moves, just for the heck of it. So the way that you mate these panels is going to matter a lot, because we want this thing to move, right? So you're just going to create a hinge basically using edges on these panels. So I selected those two edges. Now I need to constrain it in this direction, so I'll just choose that middle point. That is nice and easy. So it only takes the two mates to make this sort of hinge. So I'm gonna continue to do that for the rest of the panels. All right. So here is the final model. You can see that it moves just like the paper model, just like we wanted it to. So here's a physical model that I made. You can see that I kind of changed the shapes of the panels a little bit, and you can do that. And then for the offsets, I just made them the same thickness as the material, and I just cut all of this out on the laser. And then I used duct tape for the hinges, used it on both sides, and you have a cool little thick origami model. Okay, there are two more things that I need to show you that the last model didn't allow me to. So we're going to rewind back to this point when we have this stacked model. And we're going to choose a different location for the joint plane. We're going to choose this plane between panels 1 and 2. So I'm just going to mark that. And that's going to mean that we will have to deal with some of these joints a little differently, especially this one. That is because in the last model, the furthest any panel was away from the joint plane was one material thickness. Here, this top one, panel 4, is 2 thicknesses away. So that's going to change this joint a little bit, and I'm going to put that in and show you why I did what I did. Okay, so let me show you these two panels. I'll show you what I've done with this joint. So this shape, or this panel, number 3, I pretty much added an offset on the inside of that shape. Whereas on panel 4, the one that's further away from the joint plane, I've added it to the outside of that one. So you can imagine this panel being able to fold over 180 degrees this way. So that's how you deal with two panels that have a joint when they're both on the same side of the joint plane. But you can see that we have some interference here. So how do you deal with that? This is just something that is kind of a trade-off with the offset panel technique. You get the motion, and you get the full range of motion and the kinematics, but you have to deal with some interference. So all we're going to do, we're going to just cut a hole pretty much in this panel so that so those offsets can fit through it. The offsets are now able to return to the joint plane. And I am going to whip up a model real quick to show you how it still moves. Okay, so here is the model that moves. You can see that there are some other areas where we would have to worry about interference, but you take care of those pretty easily.